Alrighty, so we are starting a brand new unit today, and most of what today is actually a review from what we've already talked about, what you've learned in past years, but we are going to be talking about graphing parent functions. Okay, so let's first go ahead and define what parent functions actually are, what that means. Okay, so a parent function, think of it as the simplest form of the function. Kind of like the original, okay? Nothing's been added to it. It is the original parent function. Okay, so we're going to be talking about 8 different types of parent functions. And most of these guys we've actually already graphed. So like I said, a lot of this is going to be review, okay? So let's go ahead and look at number 1. So here is our equation. Y equals X. Super simple equation, okay? All of these parent functions are going to look super simple like this, okay? So first it wants us to graph and then name the type of parent function it is. So each of these guys does have a name, okay? So first of all, let's go ahead and graph it. Now, how we are going to graph all of our functions today is using a t-chart, okay? And the great thing about graphing any type of function is that a t-chart will always work, meaning you're choosing a value to plug in either for the x or the y, and then you're plugging it into the function, and then you get the outcome, okay? You have an input and an output, okay? So let's go ahead and just choose a couple different numbers for my x, my input. I'm gonna choose a couple negatives. Let's do -2, -1, 0, 1, and 2. Okay, so what this means is I am going to take each of these values, plug it in for my x, that's my input, and it will give me my y when I solve it out. Okay, so let's go ahead and do that. Okay, if I were to plug in -2 for my x, it'll look like this. Y equals -2. It used to be y equals x, well now it equals y equals -2. Okay, and look at that. We don't have to do any solving with this guy, so this one's actually going to be super easy. Okay, when I plug in -2 for x, I get out -2 for y. Same thing for -1. If I plug in -1 for x, I get out -1 for y. Okay, and this pattern follows for all of these values. If I plug in 0, I get a 0. If I plug in 1, I get a 1. If I plug in 2, I get a 2. Okay, well now this becomes just like any other function that we graph. These become our coordinate points. Okay, so I'm going to put some parentheses around them telling us that these are our x comma y's, our coordinate points. So let's go ahead and put them on our graph. Okay, so I'm going to find -2 for my x and then go down to -2 for my y. And there's my first point. Okay, second one, -1 comma -1, -1 for my x, -1 for my y. Second point. Okay, 0, 0, right there in the middle of my graph. Now +1, +1, 1 for my x, 1 for my y, and last one, +2, 2, right there. Okay, and you could go on forever, honestly, with these guys, but we have plenty of points to connect it. Okay, so we'll just connect those points with our line, arrows at the end, because this function does go on forever. Okay, and this kind of shows us what type of function this is. So we notice that it creates this straight line when we put these guys on a coordinate plane. Okay, this is what we call a linear function. Okay, so that is the name of this parent function, a linear. Beautiful. Okay, so there is our first parent function. This was the first function you pretty much talked about graphing and solving our linear functions. Alrighty, okay, so let's look at this guy. Okay, so this time we have a number thrown in, and then in our exponent spot, we have an x. Okay, well, I'm going to graph it the exact same way. I'm going to use my t-chart. I'm going to choose values to plug in for my x and solve to get my y's. Okay, so let's see. I'm going to choose some negatives again. So let's do -1, 0, 1, and 2. So I'm just going to do 4 values to plug in this time. Okay, so let's go ahead and plug these in and see what we get out for our y's. Okay, so I'm going to first plug in a -1 for my x. So this is going to look like y equals 2 to the power of -1. Okay, well, now we need to review our exponent rules. We can never have a negative exponent, and what that actually does is it becomes a fraction, moving that 2 to the denominator. So in other words, that's 1/2. So when I plug in a -1 for my x, I got out 1/2 for my y. Okay, let's try our 0. If I were to plug in y equals 2 to the power of 0, okay, well, we know anything to the power of 0 is always 1. So when I plug in a 0, I got out 1. Okay, let's do our last two. If I plug in a 1 for my x, 2 to the power of 1, 2 to the first power is just 2. Okay, so when I plug in a 1, I got out 2. And our last one, if I were to plug in 2, so 2 to the power of 2, or 2 squared, that's going to give me 4. Okay, so I did all my inputs, got my outputs. These become my coordinate points. I'm going to put my parentheses around them. And let's go ahead and graph these guys. Okay, so I have -1 for my x and then up 1/2 for my y. So -1 for my x, up 1/2, about right there. Okay, my next coordinate point is 0, 1. So 0 for my x, up to 1 for my y. Okay, then I have 1, 2. So 1 for my x, up to 2. And then my next one, 2 for my x, 4 for my y. So 2 for my x, up to 4. Okay, and we have enough points to connect this guy. So this is going to look like this. It's never going to pass into those negatives, okay, because the smaller we get, meaning if I were to plug in -2, -3, so on and so forth, our fractions would just keep getting smaller, but they're never ever going to cross into that negative because we can't have a negative exponent. Okay? Well, the name of this parent function we could have just seen right off the bat because our x is in the exponent spot. This is called an exponential. So whenever you see that your input, your x, is in an exponent spot, it's our exponential. Beautiful. All right, let's go to our next one, number 3. Okay, so I have my function y equals x squared. Okay, same thing. I'm going to get my t-chart, choose values for my x, solve to find my y's. Okay, so let's see. Let's do a couple negatives, -1, 0, 1, 2. I'll just choose those ones again. All right, so let's go ahead and plug these in for my x's to see what we get out for my y's. Okay, so if I were to plug in -1 for my x, this would be y equals -1 squared. Okay, well, -1 squared, or -1 times a -1, is going to give me +1. Okay, if I were to plug in a 0, so y equals 0 squared, well, 0 times 0, still just 0. Okay, let's plug in a 1. Y equals +1 squared, or 1 times 1, +1. Okay, let's do 2. So if I have 2 squared, it's going to give me 4. Okay, and I actually want to add one more that I want to plug in just so we could see it on the graph. I want to see what I would get if I were to plug in a -2. Okay, so when I plugged in a +2, I got +4. Let's see what I get when I plug in a -2. So y equals -2, and I'm going to put this in parentheses because the entire negative is squared. Okay, well, I know that negative times a negative is going to be a positive, 2 times 2. So again, +4. Okay, so I got all my inputs, got my outputs. These become my coordinate points, so let's go ahead and put them on our graph. Okay, my first coordinate point is -1, +1, so -1 for my x, up to +1 for my y. 0, 0, right there in the middle. +1, +1, right there. Okay, now I have my positive 2, positive 4, positive 2, positive 4. But then I chose to see what I got with negative 2, and I also got a positive 4. So negative 2 for my x, up to positive 4 for my y. Okay, and you guys have seen this shape before. This is a lot of what you guys talk about in secondary math 2. Okay, it creates this parabola, and I'm actually going to put that word on our paper because we're probably going to see it again. Okay, this is the shape of the graph. This is not the name of the parent function. Okay, this U shape is what we call a parabola. In fact, I'll even do this. Little U shape equals parabola. Okay, but the name of this parent function is what we call a quadratic, which you guys have heard a lot. Quadratic parent function. Beautiful. Okay, let's go to our next one. Alrighty. Okay, so now my new function is y equals the square root of x. Okay, so same thing. Let's get our t-chart. Notice, like I said, it's working for every single function. Use a t-chart, plug things in, see what you get. Going to choose things to plug in for x, see what we get for y. Okay, so the trick here is that I want to choose numbers that can be square rooted. Okay, and what I mean by that, if we were to choose some random number like 7 to plug in, what is the square root of 7? Well, that's going to be some horrible, hideous decimal, right? I want to choose numbers that I know will give me a pretty number when I square root it. For example, okay, I know 0 is a perfect square. I know 1 is a perfect square. And I know 4 is a perfect square. Okay, so I'm actually going to choose those 3 numbers to plug in. Because they are perfect squares, I can square root them and it'll give me a pretty number. Okay, well, let's do it. So I have 0 first. Okay, so I'm going to plug in 0 for my x. Well, the square root of 0 is just 0. So when I plug in a 0, I get out a 0. Okay, then I'm going to do my square root of 1, and the square root of 1 is also just 1. So when I plug in a 1, I get out a 1. Okay, this pattern does not follow because when we plug in a 4, okay, well, what is the square root of 4? That is 2. Okay, so when I plugged in a 4, I could get a 2. The next perfect square number that I could plug in would be 9, right? 9 is a perfect square, but we don't have that on our graph, so we're just going to go up to 4, okay? Alrighty, so those 3 points I'm now going to put on my graph. Okay, so my first point is 0, 0. Next point, 1, 1, so positive 1, positive 1. Next point, positive 4, positive 2. Okay, now here's the thing. You are not going to go into the negatives, so it's going to look like that when you connect it. Okay, because getting a negative, there cannot be a negative square root. Okay, you cannot square root something and have it be, or square something and have it be negative. Okay, so there can be no negatives. It's going to start right at that 0, 0 and just keep going that way. Okay, well, what is the name of this parent function? Okay, it's actually pretty simple. It's a square root function, and that is its name, a square root. Beautiful. Okay, so we've talked about 4 of our 8 parent functions. Let's keep going. All right, so our next one, we have y equals x cubed this time, not x squared, but x cubed. Okay, but we know how to do these now. Get your t-chart, choose things to plug in for x, see what they give you for y. All right, so let's see. This one, I can do negatives here, so I'm going to choose a negative number. Let's do negative 1, 0, 1. We'll see if we want any more after that, but let's just start with those 3. Negative 1, 0, and 1. Okay, well, let's go ahead and plug them in. So first one I'm plugging in is negative 1. Y equals negative 1 cubed. Okay, when you have that negative, let's put parentheses around it because that cubed is attached to the 1 and the negative. Okay, well, if we are to cube root a -1, this means we're taking -1 times -1 times -1. Well, we know that two negatives make a positive, but then if I were to multiply that to another negative, then I get out a negative. So -1 cubed is also -1. Okay, well, let's see what we get when we plug in 0. 0 is a great number. 0 cubed, or 0 times itself 3 times, is still just 0. Okay, let's see what we get when we plug in +1. Okay, we don't have any negative things to worry about here, so 1 times 1 times 1 is still just 1. All right, and I think we're good with just those 3 coordinate points. So let's go ahead and put those on our graph. Okay, so my first coordinate point is -1, -1. So -1 for your x, -1 for your y. Next coordinate point is 0, 0, right there in the middle. And next one, 1, 1. Now, here's the thing. This looks like it's going to create a straight line, okay? Maybe I will do, yeah. Yep, let's do 2 more because I don't want you guys to think that this is creating a straight line, okay? Just seeing those 3, I could connect those with a straight line, and that actually is not what this graph looks like. So let's do it. Let's do 2 more numbers to plug in. Let's do -2 and +2. Okay, so let's plug those guys in for my x and see what we get out. Okay, well, -2 cubed. Okay, remember this is like saying -2 times -2 times -2. So let's see what that's going to give me. -2 times a -2 is going to give me +4. And then if I were to take +4 times another -2, that's going to give me -8. Okay, so when I plugged in a -2, I got out a -8. Okay, now let's try +2. If I just have 2 cubed, well, no negatives to worry about here. This is just going to be 2 times 2 times 2. So 2 times 2, 4, times another 2 is just +8. So when I plugged in +2, I got out +8. Okay, these 2 coordinate points are really going to show you the shape of this graph now. Okay, so let's go ahead and put these on our coordinate plane. So if I plug in -2 for my x, and I got out -8 way down there, and then I plugged in +2 and got out +8. Beautiful, fit perfectly on this graph. Okay, so you'll notice this is not a straight line. It's kind of like this skinny S looking thing. Okay, but there is our parent function for this guy. Now we just need the name of it, okay? Well, if we have x cubed, this is what's called a cubic function. Beautiful. Alrighty, okay. And this kind of actually leads into our next one. These guys are related. Hint, hint, they're actually inverses of each other. Okay, so now instead of x cubed, we have the cube root of x. So let's go ahead and do our t-chart. But we're going to treat this guy just like we did our square root, where I only want to choose numbers that when I plug it in for x, it can be cube rooted. Okay, so I'm going to choose, let's do a -1, and let's do a 0. Let's do a +1, and let's do an 8. Okay, and if you're like, I wonder where she's getting these numbers. Okay, hint, hint, look at these guys over here, -1, 0, 1, and 8. Okay, let's see what we get out. Okay, if I plug these numbers in for my x, so I have y equals the cubed root of -1. Okay, well, if we just go backwards, the cubed root of -1 is still -1. Okay, next one, easy peasy. The cubed root of 0 is 0. So when I plug in a 0, I also get out a 0. Okay, next one, the cubed root of positive 1 is also positive 1. So you plug in 1, you get out 1. Okay, but then this one, if I were to plug in the cubed root of 8, so I'm actually going backwards here. The cubed root of 8 is going to be positive 2. Okay, so now I have all my outputs. Okay, and remember how I said these guys are the inverses of each other? Well, what do we know about inverses? The x's and the y's just flipped. Hint, hint. My y's became my x's. My x's became my y's. Ooh, cool. So let's see what it looks like on the graph. Okay, so I have my coordinate points here. -1, -1, right there. 0, 0, 1, 1. But this time my x is 8 and my y is 2. Okay, and if I were to do the other -1, okay, well that means my x would become -8 right there, just to give us another point. My y would be -2. So if I were to plug in that -8, I would get out that -2. Okay, and these became our coordinate points. I'm just gonna finish putting the parentheses around them. Okay, so then my last coordinate point would be -8 for my x, -2 for my y. And look at this guy, it's just kind of been like flipped on its side. So instead of tall and skinny, it's like long and flat, which is pretty much exactly what we've talked about with inverses of each other. Okay, well now what's the name of this guy? So if this guy was a cubic function and we took the cubed root of x, well that's exactly its name, the cube root. Not the square root, but the cube root. Okay, last two functions to talk about. Our next one. Okay, so these lines right here, these are what we call the absolute value lines, okay, or distance from x. Distance from x. Or not, excuse me, not x, 0. Distance from 0. Okay, so I have my t-chart. I'm going to choose the numbers to plug in. I'm going to do a couple negatives here. -2, -1, 0, 1, and 2. Okay, let's plug them in and see what we get out. So I have y equals the absolute value of -2, meaning how far or how many units away from 0 is -2? Well, it's 2. It's +2. Okay, because we know whenever you have an absolute value of a negative number, it just gives you the positive of that number. Okay, and I could keep going. So I got out +2 with -2, +1. Okay, well now these guys are kind of easy. Absolute value of 0 is 0, because it's right on 0. Okay, well how far away is 1 from 0? It's 1. So the absolute value of 1 is 1. And the absolute value of +2 is also 2. And there we go. There are our coordinate points. Let's go ahead and put them on our graph. Alrighty, so -2, +2. -1, +1. 0, 0. +1, +1. And +2, +2. Okay, now here's the thing. You might look at this and say, oh, this is kind of like that U-shape, that parabola we talked about. But with absolute value, it is not a U-shape, okay? It is more like a V. Okay, so there is the shape of our absolute value. And you guessed the name of it. It is just called an absolute value parent function. Awesome. Alrighty, our last one. Okay, so notice we have this log in our function. Okay, so let's go ahead and just name this one. Since we have the log, we know this guy is a logarithmic. I think I spelled that right. Logarithmic function. Okay, so we talked about this. This was actually one of our first units this year. we talked about graphing logarithmics. And the thing about graphing a logarithmic before I can do my t-chart is I need to convert it back into an exponential, because remember, exponentials and logs are inverses of each other. So I want to convert it back, which means I am going to take, oh, let's do log base 2. I forgot the 2 in there. Sorry. Log base 2 of x. Okay, so to convert it back into an exponential, you're going to grab your base, go around the equal sign. So now I have 2 to the power of y, and go back, equals x. Okay, so before we can do our t-chart, you have to convert it back into an exponential, which is going to be 2 to the power of y equals x. Okay, well now I can do my t-chart. Okay, but if you remember from way back at the beginning of the year when we talked about logarithmics, okay, it would be way easier to plug things in for y to get x, okay? If you're plugging things in for x, you kind of have to guess, okay? 2 to the power of what equals something? Yeah, no, let's plug things in for y this time. Okay, so I'm going to take -1, 0, and +1. This time I'm plugging things in for y. Okay, well, let's see what we get. Okay, so if I have 2 to the power of -1 to give me my x, well, what is that going to be? We know that we can never have a negative exponent. Changes it to a fraction, 1/2. So when I plugged in -1 for my y, I get 1/2 for my x. Okay, well, let's see what we get for 0. 2 to the power of 0 to give me my x. Well, anything to the power of 0 is 1. So my x is going to be 1. And then when I plug in a 1, 2 to the power of 1 to give me my x, well, it's just going to be 2. Okay. 3 coordinate points is plenty, so let's go ahead and put it on our graph. So I have 1/2 and then down to -1. 1/2 for my x is about right there, down to -1, right there. Okay, then my next coordinate point, 1, 0, right there. And my next coordinate point, 2, 1. Okay, so if you look back at your exponential, you'll notice that it gets really close. In fact, let's look at it. So with an exponential, it's getting really close but never passing. The same thing is happening with a log, except it's the different axis. It's never going to go past that x-axis. It's going to look something like that. And there we go.